so this is our lesson video for section 4.3, and so we are going to finish up talking a little bit about atoms. So elements are different because they contain different numbers of protons. Now a lot of times if I ask you what's different about calcium and strontium or something like that, a lot of you want to say it's the electrons, protons, and neutrons, but an element is actually only identified by the number of protons. We'll talk about in this section actually how they can differ in number of neutrons and still be the same element. And in another chapter we'll talk about how they can gain and lose electrons and then become ions. So if you're ever asked about the identity of an element, it is strictly based on number of protons or the atomic number. So the atomic number of an element is of course the number of protons in the nucleus of an atom of that element. The atomic number identifies an element. So remember, an element is identified by number of protons because neutrons can be different in different isotopes, and once it gains or loses electrons and becomes an ion, then those can be different also. So atoms are electrically neutral. If they gain or lose electrons, again later in chapter 7 we'll learn how then we call them ions instead of atoms. So the number of protons equals the number of electrons in a neutral atom. So if an atom has 5 protons, which are positive, it must have 5 negative electrons to cancel it out and become neutral. Again though, atoms can gain and lose electrons, and once that happens we refer to them as ions instead. So the element nitrogen, which is N, is shown here in liquid form. It has an atomic number of 7. So how many protons and electrons are in a neutral nitrogen atom? So since it tells us it's neutral and it tells us it's an atom, we know the protons and electrons are the same. Well, the atomic number, which it tells us is 7, is the number of protons. So there are 7 protons, and then because it's neutral, there are 7 electrons. Now, if you're looking at my notes packet while you're watching this video, some of these questions I felt were way too easy, like you'll especially see some in a few minutes where it's like the same answer over and over and over again. So I didn't necessarily put all of them in the notes packet, so just keep skipping through the notes packet. Alright, so here's an example of something super easy. So it says complete the table. So our element is K, which hopefully you already know that is potassium, and it says its atomic number is 19. Well, protons is the atomic number. So the number of protons would of course be 19 also. Now, we are assuming that this is an atom, not an ion, since we haven't actually learned ions yet, so of course our electrons are 19 also. Alright, so here we don't know the element atomic number of protons, but we know there's 5 electrons. Well, since it's an atom, that means there has to be 5 protons. If there's 5 protons, that means the atomic number is 5. And so then, what element is it? Well, if you look at the periodic table, if you have a periodic table in front of you, look at the atomic numbers. Those are the whole numbers that are usually listed above the symbols. And so if you look at element number 5, it is boron, which is a capital B. Alright, here we have S. It says atomic number 16, so that means it has to have 16 protons, because remember, atomic number is the number of protons. Since it's an atom that must be neutral, it has to have 16 electrons. Alright, and then last one is V, which is vanadium. So you can either look at the periodic table and see it has an atomic number of 23, or you can say, well, it has 23 protons, so it has to have an atomic number of 23, and so to make it neutral, the electrons also have to be 23. So again, this chart's super easy. 19, 19, 19, 5, 5, 5, 16, 16, 16, 23, 23, 23, and boron. So again, that's probably why I didn't put it in your notes packet. So number 2, it says how many protons and electrons are in each atom. So we have fluorine. So again, all you do is go to your periodic table, which hopefully you have one. If you are in my class, I've given you multiple ones at this point. If you're not, you can print one off the internet. But you find fluorine, which the symbol for fluorine is F, not FL. So you find fluorine, you look at the whole number above the symbol, which for fluorine is going to be 9. So since the atomic number is 9, that means it has 9 protons. Since it's an atom, it also has 9 electrons. Okay, I'm not going to write all this down because I feel like this is pretty easy at this point. Alright, calcium. Calcium is Ca. So you'll go to your periodic table, find Ca, look at the number above the symbol. It's going to be a 20. So atomic number is 20, which means 20 protons. Since it's an atom, that means 20 electrons. So you need to be very careful though, because if they were asking about an ion, the number of electrons would change. So just be careful whenever you're doing a practice sheet or something like that. Make sure we're talking about atoms, before you assume protons and electrons are the same. And then last one is aluminum. Aluminum is Al, so you'll find Al on your periodic table, and of course above the symbol it's going to have a 13. Atomic number is 13, so that means there's 13 protons and 13 electrons. So hopefully you're catching on. Atomic number is number of protons. If it's a neutral atom, it's the number of protons must equal the number of electrons. Because remember, protons are positive, electrons are negative, so to be neutral they have to cancel. So let's move on to talk about the mass a little bit, because we've talked about that atomic number. So most of the mass of an atom is concentrated in the nucleus, which is made of the protons and neutrons. The electrons are much, much less mass. So it would be, I always say it'd be like if you step on a scale, and then I tell you to hold a paper clip and step back on the scale to see how much your weight or mass changed at that point. It's not really going to be that much difference because a paper clip is so small compared to the rest of your body. So that's kind of what the electrons are like compared to the nucleus. It's just like adding a little paper clip onto a full-size person. So we don't include them in the mass because they're just so tiny. They do have mass though, it's just very, very small. So the total number of protons and neutrons is the mass number. So the mass is in the nucleus, the protons and neutrons. The number of neutrons in an atom is the difference between the mass number and atomic number. And so of course we know difference mathematically means subtracting. So if you do your mass number, which is protons and neutrons, minus your atomic number, which is just protons, then of course you're going to get the number of neutrons. So sometimes you're going to see shorthand. I like to use shorthand because I don't want to have to do a copy of the periodic table on every question. So atomic information can be written in two forms of shorthand. The first form is the symbol of an element with the mass number as a superscript and the atomic number as a subscript. So here's an example. Au is gold, hopefully you already knew that. And then we have our mass number as a superscript, so it's kind of raised a little bit, kind of like a power would be in math, except it's on the left side. And then the atomic number is as a subscript. It's going to be backwards than the way you would see it on the periodic table, so that confuses some of the students. On the periodic table, the atomic number is normally above the symbol and the atomic mass is below the symbol. But when we write shorthand, we write our mass number as a superscript and our atomic number as a subscript. And so then that makes for easy subtracting to get the number of neutrons. The second form of shorthand is the element name followed only by the mass number. So for example, gold-197. Notice in this form of shorthand, they don't tell you the atomic number at all. The reason that happens is because the atomic number of gold is never going to change. It is always going to be 79 or it's not gold. The mass number, on the other hand, can change depending on which isotope you're looking at. And so we'll talk about isotopes in just a minute. So you have to know the mass number of whichever isotope you're looking at. That's why this number is a whole number, whereas if you look on the periodic table, you're going to see a bunch of decimals. There's a difference in the mass number and the atomic mass, and we'll talk about that also. Alright, so on the periodic table, the element symbol is normally in the middle, and then the atomic number is on top, and the atomic mass is below. Okay, so like if I was looking at a box on the periodic table, this is normally the order that it's going to be in. So, how many protons, electrons, and neutrons are in each atom? So again, here they tell me it's an atom, so I know it's neutral. So I will actually put my answers up here. So I'm going to do a P plus for protons, an E minus for electrons, and an N0 for neutrons. Those are some shorthand forms of both of those. Alright, so beryllium, it says it has atomic number of 4 and a mass number of 9. Well, protons is atomic number, so I know that means there's 4 protons. Electrons must equal protons in a neutral atom, so I know there are 4 electrons. And then to get neutrons, you do mass number minus atomic number. So 9 minus 4, which gives me 5. Alright, so let's look at the next one. So we have neon. It has atomic number of 10, mass number of 20. So protons is the atomic number, so that's going to be 10. Electrons must equal protons in a neutral atom, so electrons will also be 10. And then neutrons is mass number minus atomic number, so 20 minus 10 is 10. Alright, and then the last one, we have sodium, atomic number 11, mass number 23. So remember, protons is the atomic number, so protons is 11. Electrons equals protons in a neutral atom, so electrons is also 11. And then neutrons, we do mass number, because mass number is protons and neutrons, whereas atomic number is just protons. So if we do mass minus atomic, we get rid of the protons, and what we're left with is neutrons. So 23 minus 11 is, of course, 12 for neutrons. All right, so hopefully you're getting the hang of this, because you want to be able to do these type of problems really quickly on the test. You want to be able to save, your time for a little bit more difficult problems. All right, so it says how many neutrons are in each atom. So remember, in this form of shorthand, the top number is the mass number, and the bottom number is the atomic number. And so as we just said in the previous slide, you just subtract to get number of neutrons. So 16 minus 8 is 8 neutrons. 32 minus 16 is 16 neutrons. 108 minus 47 is 61 neutrons. 80 minus 35 is 45 neutrons. And 207 minus 82 is 125 neutrons. All right, so one thing to keep in mind is if you're not super great at mental math, then you can always use a calculator in my class. All right, so the next one, it says express the composition of each atom in the other type of shorthand. So they gave me the name and the mass number. Remember, if you get this form of shorthand, this is the mass number. We need to get it into this form of shorthand. All right, so we need mass number on top and atomic number. So notice, did they give me the atomic number? No. So where can I find it? The periodic table. You can always find atomic number on the periodic table because it cannot change. Mass number, not so much. Remember, it has the atomic mass, not the mass number on the periodic table. A lot of you think if you just round to the atomic mass, that's the same thing as mass number. Not so much. All right, so first, the difference is these have the symbols. So what's the symbol for carbon? It is a C. All right, then I need the mass number as a superscript, so I put my 12 up top. And then I need my atomic number as a subscript, so I go to the periodic table. Sorry, I'm pointing this way because in my classroom, my periodic table is right over there. Hopefully you have one in front of you. So you go to your periodic table, look at carbon, it will tell you that the atomic number is 6. So carbon with a 12 over 6 is carbon 12 in the other form of shorthand. All right, so let's move on. Fluorine, symbol is F, not FL. All right, I need my mass number on top, which they gave me right here, is 19. So I'll look at my periodic table. The atomic number for fluorine is 9, so I'll put my 9 on bottom. All right, and then last one, we have beryllium, 9. Beryllium, the symbol is Be. I need my mass number on top, which they gave me right here, is a 9. And then I need my atomic number on bottom, and so if you look at Be on the periodic table, you will see that it is 4. All right, so hopefully you're kind of getting a little more comfortable with those different forms of shorthand. Remember, this one gives you mass number on top, atomic number on bottom. This one just gives you mass number. You can always find atomic number on the periodic table, which in my class, you will always have a periodic table on each test. If you're not in my class, I don't know how your teacher is planning on doing it. All right, woo, got a little fancy there. All right, so isotopes, finally, we'll talk about those for a second, are atoms that have the same number of protons, so they are the same element, but they have different numbers of neutrons. So that's why I tell you an atom can't be identified by its number of neutrons. Because isotopes of an element have different numbers of neutrons, they also have different mass numbers. Okay, so here's 3 examples of isotopes of neon. So this is neon 20. Because it's neon, it has to have 10 protons, because neon has an atomic number of 10. Because it's an atom, it also has to have 10 electrons. And then because it's neon 20, this one has 10 neutrons, because of course protons plus neutrons must equal your mass number. So 10 plus 10 equals 20. Well, this is a different isotope. It's neon 21. It's still neon, so it still has 10 protons and 10 electrons because it's an atom. But because it's neon 21, that means it has 11 neutrons. So again, they're both neon atoms, but this one just happens to have an extra neutron. All right, and then the last one is neon 22. So again, it's neon, so it has 10 protons and 10 electrons. But because this one's neon 22, that means it has 12 neutrons. Okay, so notice, remember, in this form of shorthand, this number is the mass number. So notice the masses are different, and the neutrons are different. The protons and electrons remain the same. So it says 3 isotopes of oxygen are oxygen 16, oxygen 17, and oxygen 18. Write the symbol for each, including atomic number and mass number. So in other words, they want the other form of shorthand. So what's the symbol for oxygen? It is O. I'm just going to go ahead and do it 3 times because we're going to do it for O, oxygen 16, 17, and 18. So remember, in the other form of shorthand, we do the mass number on top and the atomic number on bottom. So for oxygen 16, the mass number is 16. The atomic number, which I can pull from the periodic table, is 8. So oxygen 16, the other form of shorthand is this. For oxygen 17, the mass is 17, and again, I can pull my atomic number from the periodic table. And then for oxygen 18, the mass is 18, but atomic number stays the same. So that's the important thing to notice is in an isotope, the symbol stays the same, the atomic number stays the same, it's just the mass that changes because the number of neutrons change. All right, so it says 3 isotopes of chromium are chromium 50, chromium 52, and chromium 53. How many neutrons are in each isotope? Well, first thing is we need to figure out what the atomic number is. So chromium on the periodic table is Cr. All right, and then if you look at the periodic table, its atomic number is 24. All right, so in other words, all I need to do is subtract each to do neutrons. So I need to do like 50 minus 24, 52 minus 24, 53 minus 24. So I'm just going to put kind of the number of neutrons under each one, so hopefully that'll help. All right, so 50 minus 24 is 26. So for chromium 50, I have 26 neutrons. So for chromium 52, I have 28 neutrons. And then for chromium 53, I have 29 neutrons. Okay, so all I had to do for this one was find the symbol on the periodic table and find that atomic number, so I could subtract my mass minus atomic number to get my number of neutrons for each. All right, so let's continue talking about isotopes for a minute. So the atomic mass unit, which is also called AMU, is defined as 1/12 of a carbon-12 atom. Atomic mass is measured in AMUs. In nature, most elements occur as a mixture of 2 or more isotopes. The atomic mass of an element is the weighted average mass of the atoms in a naturally occurring sample of the element. So this is where we're going to talk about the difference in mass number and atomic mass. Mass number is, in a specific isotope or atom, the number of protons plus the number of neutrons in the nucleus. It's going to be a whole number. Atomic mass is the weighted average mass of atoms in naturally occurring sample of the element. So what weighted average mass is like your grades. So think about when you go into Infinite Campus and you have your class grades and then you have your final exam grade. Your final exam grade counts as a different percentage than your class grades do. And sometimes tests might count as a different percentage than a practice sheet or something like that. So your grade in Infinite Campus is a weighted average. And so if you notice when you go on Infinite Campus, you rarely actually have a whole number average. Like if you go on Infinite Campus and see 84, if you look right under it, it'll say like 83.962 or something like that. And so that's why our atomic masses on the periodic table will have those decimal points. Because a lot of people think, well, if you can't have part of a proton or part of a neutron, how can you have a decimal? Because it's that weighted average of all of the different isotopes. So it says the atomic mass of copper is 63.546 AMU. Which of copper's 2 isotopes is more abundant, copper 63 or copper 65? So the way you do a problem like this is the more abundant the isotope, the closer the average atomic mass will be to that number. So all you have to do is say, okay, was 63.546 closer to 63 or closer to 65? Well, 63.546 is closer to 63, so that means copper 63 has to be more abundant. That's all you do on this type. Okay, so copper 63 would be the most abundant for that. So maybe try these 2 real quick on your own, and then let's look at them. So it says boron has 2 isotopes, boron 10 and boron 11. Which is more abundant given that the atomic mass of boron is 10.81? Was 10.81 closer to 10 or closer to 11? That's closer to 11. So boron 11 would be more abundant. All right, then it says there are 3 isotopes, that should say of silicon. They have mass numbers of 28, 29, and 30. The atomic mass of silicon is 28.086 AMU. Comment on the relative abundance of these three isotopes. Well, if you look, the atomic mass is 28.086. So if I was going to comment on the relative abundance, I would say, well, clearly 28 must be most of the abundance, seeing how it's 28.086. And so then I would say that 29 and 30 have a much lower abundance. All right, so for this number 2, I would just say 28 has a really high abundance and 29 and 30 have a much lower abundance. Now let's say that we want to actually calculate the atomic mass. We're not just going to compare and talk about relative abundances. This is the same thing you do to calculate your average. So if you already know how to calculate your average, it's the same thing. So to calculate the atomic mass of an element, you multiply the mass of each isotope by its natural abundance expressed as a decimal and then add the products. So, for example, carbon has 2 stable isotopes, carbon 12 and 13. Carbon 12 has a mass of 12 AMU and an abundance of 98.89%. Carbon 13 has a mass of 13.003 AMU, which has a natural abundance of 1.11%. So all we do is take the mass, let's see, we took our 12 AMU, and multiply it by the percentage as a decimal. So if you know anything about math, you know that the way to get a percentage in decimal form is divide by 100 or move the decimal to the left twice. So in other words, 98.89% becomes 0.9889 in decimal form. And so 1.11% would become 0.0111 in decimal form. And so you can see that then they took the 13.003 AMU and multiplied by the 0.0111 AMU. And so then once you multiply and add those two together, you get 12.011 AMU. And if you look, that's what it is on the periodic table. All right, and so that's all you do. So let's look at a couple of these. We'll do the first one together. All right, so it says element X has 2 natural isotopes. The isotope with a mass of 10.012 AMU has a relative abundance of 19.91%. The isotope with the mass of 11.009 AMU has a relative abundance of 80.09%. Calculate the atomic mass of this element. So this is all you do. You take the mass, so 10.012 AMU, and you multiply it by its percentage as a decimal. So remember, either divide this number by 100 or move the decimal twice. So I'm going to multiply it by 0.1991. Then I'm going to add, oops, sorry, that's an addition, my other one. So I have 11.009 AMU times this number as a decimal. So you can either divide by 100 or move the decimal twice. So once I multiply these two, notice they're in parentheses, so follow your order of operations, and add them together, I'm going to get, let's see, 10.81, and then my unit is AMU. I'm super, super picky about units. So if you get 10.81 and don't put the unit, it's automatically half off. It doesn't matter how much the problem counts. All right, so make sure you put units. I'm going to tell you the units AMU in the problem, so it's not like you have to remember it. All right, so this is how you do these. Now, of course, you can split it up into 2 steps if you would prefer to do that. So, for example, if you would prefer to multiply, get an answer, multiply, get an answer, and then add them, you get the same answer. Okay, I just think it's a little easier to just do it all in one step in your calculator. All right, so maybe you pause the video, try the next 2, or if you want to watch me do one more and then you can try the last one, anything works, just make sure you're able to do them on your own. So it says the element copper has naturally occurring isotopes with mass numbers 63 and 65, and so I'm not going to read the whole thing. It gives us our percentages and it gives us our masses. So let's go ahead and calculate that average atomic mass. All right, so I'm going to take my mass. So my first mass is 62.93 AMU and multiply it by the abundance. So remember, I'm going to take that decimal and move it 2 times to the left. So I'm going to multiply it by 692. And then I'm going to add my other one. So my other mass is 64.93 AMU. And I'm going to multiply it by my abundance as a decimal. So remember, divide by 100 or move that decimal 2 spaces to the left. And so once I multiply and add everybody together, I get 63.55 AMU. All right. So let's move on to our next one. All right, so it says calculate the atomic mass of bromine. The two isotopes of bromine have atomic masses and relative abundances of 78.92 AMU, and then there's my percentage, and 80.92 AMU, and there is my percentage. All right, so let's do this one together. So pause it. Just make sure that you know you try this one on your own. All right, so I start with my first mass, which is 78.92 AMU. And I multiply it by my abundance as a decimal. So I'm going to move this over 2 spaces or divide by 100. So I multiply it by 0.5069. And then I do the same thing for this mass and this abundance. And it doesn't matter how many isotopes something has. You just do this as many isotopes as you get. So if you have an element with 4 isotopes, you would just do this 4 different times. All right, so I take my 80.92 AMU, and I'm going to multiply it by my percentage as a decimal. So I'm going to move that over twice, so it becomes 0.4931. And so then I'm going to multiply and add, and so I end up getting 79.91 AMU. And so, of course, don't forget to put that unit, AMU, for both of them. All right? So hopefully you have figured out how to calculate that average atomic mass. Alright, so the periodic table is an arrangement of elements in which the elements are separated based on a set of repeating properties. We'll talk a lot more about the periodic table in Chapter 6, so I'm not going to dive really in depth in that. This video is obviously already long enough at this point. So notice that the elements are listed in order of increasing atomic number. So if you look, we go 1, 2, 3, 4, 5, 6, all the way down. This one ends at 110. It depends on what periodic table you're looking at as far as what it ends on. Each horizontal row of the periodic table is called a period, and each vertical column is called a group. So these rows are called periods, and then the columns are called groups. Elements within the same group have similar physical and chemical properties. Okay, so elements that are in the same column have similar physical and chemical properties, not in the same row or period. All right, so let's knock out this section assessment because this video has been long. So what distinguishes the atoms of one element from atoms of another? Remember, it is the number of protons, or atomic number. Okay, so for number 1, it's the number of protons, or atomic number. Number 2, what equation tells you how to calculate the number of neutrons in an atom? It is mass number minus atomic number. Mass number minus atomic number. Number 3, how do the isotopes of a given element differ from one another? They have different numbers of neutrons and different mass numbers. Different numbers of neutrons and different mass numbers. Number 4, what does the number represent in the isotope platinum-194? Well, this is the mass number. And then it says write the symbol for this atom using the other form of shorthand. All right, so platinum, I'm just going to put it right up here. Platinum is PT. And the mass number in the other form of shorthand is a superscript, so 194. And then you can look at the periodic table and see that PT is number 78, so then I just put my atomic number at the bottom. So this would be the other form of shorthand of platinum 194. Alright, so it says the atomic masses of elements are generally not whole numbers. Explain why. Remember, it's like your grade in Infinite Campus. It's the weighted average of all of the isotopes. All right, it's the weighted average of all of the isotopes. So number 6, it says list the number of protons, neutrons, and electrons in each pair of isotopes. Okay, so we have protons, electrons, and neutrons for the first set, and then protons, electrons, and neutrons for the second set. Okay, you can see we have a first set and a second set. So lithium, atomic number is 3. That means protons and electrons are 3 because, of course, these are just atoms. And then neutrons, I just subtract. So 6 minus 3 is 3 neutrons. But once I go to this one, lithium, it's still a 3. So my protons and electrons are still 3. For neutrons, I subtract. So 7 minus 3 is 4 neutrons. That's all you have to do. Okay? So for calcium, 20 and 42. Atomic number is 20, so it has 20 protons. Because it is an atom, it also has 20 electrons. So then I just do 42 minus 20 and get 22 neutrons. All right, and then I do this one. Calcium is still atomic number of 20, so it still has 20 protons. Protons and electrons must cancel, so it has 20 electrons. And then when I do 44 minus 20, I get 24 neutrons. All right, and then our last one, selenium. It has an atomic number of 34, so I have 34 protons. Protons and electrons are equal, so I have 34 electrons. Let's see, 78 minus 34. Let me grab my calculator real quick. I'm not great at mental math. So I have 44 neutrons here, because all I do is 78 minus 34. And so then selenium, we have 34 as our atomic number still. And our electrons are going to be 34 because it's an atom. And then I do 80 minus 34, and so I'm going to get 46 neutrons. All right, and then last one, it says name 2 elements that have properties similar to those of the element calcium. So just look at your periodic table and look for anything in the same column as calcium. So if you look, it's in the second group or second column. It starts with Be at the top. So you can pick beryllium, magnesium, strontium, any of those. Okay, so I'm just going to put Mg, magnesium, and Be, beryllium, for those 2. All right, so hopefully you understand a little bit more about isotopes and how to calculate masses.